Okay, let's go ahead and get started. Welcome back, everyone, for those of you who were at the last session, and welcome for those of you who weren't. For those of you who don't know me, my name is Scott Schnall. I'm a principal technical writer on the Exchange team, and this is part 2 of the Exchange 2013 Architectural Deep Dive. How many of you were at part 1? Okay, was there anybody who was not at part 1? Okay. So for those of you who weren't at part 1, there's a couple things I want to make clear. This is a presentation that is based on pre-release software. Okay, so any screenshots I show, any performance data I give you, all of it is pre-release and therefore subject to change, et cetera, et cetera, et cetera. So just be aware of the disclaimer with this because it's all pre-release. Some of the things might not be there for RTM. I'm not aware of anything that's at risk, but again, just for the disclaimer purposes, it's on pre-release software. The agenda, if you weren't at part 1, I will briefly recap some of the architecture changes. If you were at part 1, then this is going to give you a chance to just reinforce what we talked about a little bit ago, because it was a lot of new information. And then we're going to talk about the architecture around the other server role that we have, which is the mailbox server role. So in part 1, we focused on the client access server role. Part 2, we'll focus on the mailbox server role. Okay, can everybody hear me? It feels like my mic is cutting in and out. Everybody hear me okay? Yeah, it is? Okay, well, I'll try not to move too much here. I can readjust it, make a bunch of noise now instead of later. Okay. All right, so let's do the architecture recap. Again, the theme that we have for the new architecture in 2013 is to use what we refer to as building blocks, or what we sometimes call just bricks. But it's a building block metaphor, and that metaphor is designed to express simplicity, it's designed to express scalability, and it's designed to express the modularity of the architecture as well. So the idea is to use these building blocks so that you can build a solution basically at any scale that you need. It might be a scale just for your own organization, or maybe you're a hoster, so you've got a lot of tenants that you're supporting. It might be a larger scale such as that. Or it could be even the biggest Exchange installation on the planet right now, which is, of course, Office 365, which has well over 100 million mailboxes running in that cloud service worldwide. So that's the kind of scalability that we're talking about. We evolved the server roles as part of the new architecture. We reduced them from 5 down to 2. We simplified things with respect to the network and making sure that we were a good citizen as far as the network's concerned. And we also simplified things with respect to versioning and interop so that we can handle both down-level and up-level servers without having the customers have to do too much work in order to do that. And the benefits, of course, is you get hardware efficiency. You get to fully utilize the hardware that you have. We talked about in part 1 about the inefficiencies of some customer deployments, particularly with today's hardware. If you were to deploy Exchange 2010 on dedicated server roles, for example, you would be leaving a lot of hardware resources on the table and leaving some of your servers underutilized if you were buying new hardware today. We also get deployment simplicity. It's not really too hard to figure out the very limited set of combinations you can have with 2 server roles. With 4 that can be combined together, you've got all sorts of permutations. But with just 2 server roles, there's only 3 possibilities: co-location or individual separate roles. Okay, so it's very, very simple from that perspective. And of course, the cross-version interop. Okay, cross-version not just between the client access server and the mailbox server, but between versions of the product as well. So a client access server for Exchange 2013 being able to proxy or redirect to a client access server running Exchange 2010, for example. And the last is the failure isolation. We haven't talked too much about that. Most of that will be exposed to you in the high availability session later on this afternoon. But the point is that we have failure isolation so that if individual pieces do fail, we have new mechanisms in there now that can create new failover behaviors, can move services over, can obviously trigger database failovers, and so forth. For those of you who haven't seen it, this is what the new architecture looks like. Again, it's a building block architecture where we have just 2 internal server roles, the client access server role and the mailbox server role. If you have a group of client access servers, we call that a client access array. If you have a group of mailbox servers that are replicating databases, we call that a database availability group. So it's the same terms that you're used to from previous versions of Exchange, but they have some pretty significant differences, particularly the client access server, in terms of their meanings. But the benefits that you get is you do get loosely coupled server roles, and you do get version interoperability, and you do get geo-affinity for users and so forth. So there's many, many benefits to this new architecture. It makes things easier, makes things less complicated in terms of the deployment, and makes things much less expensive in terms of your capital costs as well. We also talked about in part one the overriding architectural tenet that we used to develop this architecture, and that tenet is every server is an island. So if you think of the server on the left as, say, the RTM version of Exchange 2013, the server on the right, on your right, would be, say, for instance, a post-RTM version of Exchange 2013, Service Pack X, if you will. The principles say that we have this separation of functionality across the product, both of the protocols, the business logic, and the storage engine. And historically, we allowed cross-functionality communication between them, but we don't allow that anymore. Because every server is an island, we force the individual components to talk to their counterparts on the other server. We won't let transport on one server, for example, talk to the mailbox role on another server. If transport has something to get to that mailbox database, transport will talk to transport on that server, and the local instance of transport will send it to that mailbox database. Again, we call this principle every server is an island. That way, anything we do to that island generally doesn't affect anything except what was on that island. Okay, so the mailboxes, the protocol access, and so forth. This cross-communication, that's banned. It doesn't exist in 2013. Still the way we do it in 2010, still the way we do it in 2007, but that cross-functionality does not exist in 2013. Every server is now an island. Okay, so that's the basics. That's a recap. Again, it's not really doing justice because it didn't go into the nuts and bolts of the client access server role, so I'd highly recommend that you download the deck and see the recording. The rest of this session is going to focus on the mailbox server role, the only other internal server role that we have in Exchange 2013. And the mailbox server role, that's simply the back-end server that is responsible for almost everything that is related to a mailbox. Storing the data, rendering the data, providing, I know I'm going to trip on that eventually, providing client access, all the client access protocols to that data, providing the unified messaging stack for that mailbox, and so forth. All of that functionality is inside the mailbox role, leaving the CAS to be nothing more than something that does authentication and either proxying or redirection, depending on the configuration. Now, the previous server roles that we used to have, the client access server role, the hub transport server role, the unified messaging server role, those are now services, and even the mailbox server role itself, we now look at as a service or a set of services on the mailbox server itself. So all those prior server roles that you're used to, almost all of them are gone. We're just left with CAS and hub. All the functionality became services, and now they live inside the mailbox role, which is where we do data storage, data rendering, data access, and data processing. Only client access servers connect directly to the mailbox server. Now, we had a similar situation in 2010. Remember, in 2010, for mailbox data access, all clients would connect to CAS, and CAS would connect to mailbox on their behalf. So that behavior is not entirely new, but what is entirely new are a couple things. There was an exception to that rule in 2010, and the exception was for public folder connections. Public folder connections were different. If a client needed public folder data, they would communicate with the RPC client access service on the mailbox server. They still weren't interfacing or logging on directly to the store, but they were talking to a service on the mailbox server instead. That no longer exists, in part because there is no more RPC client access that we need to worry about. So as a result of that, we don't have that where we're talking to it. So we only have the situation where we're just talking to everything that's on the one box, on the mailbox server. Connectivity is always going to be provided to the mailbox server that hosts the active copy of a database. So if you've got a DAG and you're replicating the database, we're only going to talk to the server that has the active copy of that user's database. Okay, the other servers are just replicas there. Okay, and that isolates everything into a nice, neat, clean, crisp little island, as you can see. So the DAG, what is that? Well, it's pretty much what we had in 2010. There are some significant differences, though. I'll talk about those in the HA session. I won't talk about any in here. But the DAG itself, from a basic perspective, is still the same construct. It's still a boundary for replication. It's still a boundary for switchovers and failovers. It can still have up to 16 mailbox servers in the DAG. Even with Windows Server 2012, that, yes, does allow many, many more servers to be a part of an underlying cluster, we are still keeping the DAG limited to 16 members. If you think you have a strong business case for why you need to grow your DAG beyond 16, send me an email message offline, and we can talk about it that way. But for now, the support stance is still 16 members in a DAG max, even with Windows 2012. DAG members can easily be in different sites. We've had this ability since Exchange 2010. This is nothing new or revolutionary, but we have made it easier in terms of namespaces and certificates, as you'll see in a bit. But otherwise, the DAG, from a basic conceptual perspective, is largely the same. But when you come to the high availability session later on this afternoon, you're going to learn about a lot of new differences that are in the DAG. So it's still the DAG and it's still mailbox servers, but there's a lot more going on under there than what a lot of people realize. And again, that's in large part because we haven't really communicated a lot of what's going on under there yet. So a lot of people, if you've been reading blogs about Exchange 2013 or articles that people have written, I'm sure you've encountered people writing that the DAG is largely unchanged and there's nothing new there. That's not true. There's a lot of new stuff there. It just hasn't come out yet. It's coming out later this afternoon, and you're going to be one of the first people to hear some of this stuff. So let's talk about mailbox-related changes. And by this, I mean what we used to call the mailbox server role and what we're now calling mailbox services. There's many changes related to mailbox. One is which we have a whole new information store. The database and the database engine is still JET, still the extensible storage engine, but we have a new, completely rewritten, brand new information store that we call the managed store. I'll talk about that in a bit. We also have more IOPS reductions. Okay, and this is another significant win. We've been able to reduce IOPS every version since Exchange 2003. In 2007, that reduced IOPS over 2003 by 70%. In 2010, that reduced it by another 70%. I'm going to save what the reduction is until I get to that. It's going to blow you away. Larger mailbox support. We're all about large mailboxes. When we started talking in the 2007 days, that was a 1 to 2 gigabyte mailbox. 2010, it was 10 gigabytes, 20 gigabytes, 25 gigabytes. For 2013, when we say large mailbox, we're talking about mailboxes that are 100 gigabytes and larger. That's what we mean by large mailbox support. Now, that's not to say every single one of you is going to go and fill a 100 gig mailbox, but what we are saying is, though, if you do have those needs, if in your information worker storing 1 to 2 years worth of data, it accumulates and is that large, we can support that no problem in 2013. And modern public folders. Somebody asked about those in the previous section, because that's a mailbox-related thing. We didn't talk about it in the CAS session, but we are going to talk about modern public folders and what they mean for you in this session. And then lastly, there's a new search infrastructure as well. We've standardized search across the Office platform on a product called FAST that Microsoft now owns. And the FAST search engine has been integrated into Exchange, into SharePoint, and in other places in Office as well. I'll talk about that in a minute. But first, let's talk about the managed store. The managed store is awesome for several reasons. First, it's brand new. And that, believe it or not, makes it the most awesome thing ever. Here's why. Up until we did this, every version of Exchange, including Exchange 2010, has carried the legacy store with it. The store that we first developed and wrote for Exchange 4.0 was carried forward to 5.0, to 5.5, to 2000, to 2003, 2007, and 2010. So over that type of lifespan, 15, 17 years, you can imagine the kind of junk that gets collected into that type of code. And sure, every once in a while, we'd go in there and rip stuff out and move stuff around and change things. But it's largely the same exact unmanaged C++ store.exe executable that we've had for more than a decade. That is gone. And in its place is the managed store. The managed store is brand new, written in C#, It's all managed code. And we use the controller worker process model. Okay, so we have what you might consider the store service, which is the Microsoft.exchange.store.service.exe. That's a controller service. It's a very lightweight service. Its lot in life is really just to track the worker processes under it. And we have the worker process. And that store worker process is one process per database. If you have 5 mailbox databases, you have 5 worker processes that are instantiated. When you dismount a database, the worker process goes away. When you mount a database, it instantiates and does its thing. And the controller service is there to manage the worker processes. If one gets hung, the controller service terminates it and causes it to reinstantiate. If we need to do a failover, the worker process gets terminated and we do the database failover. If one of the worker processes crashes, the controller service fixes that up as well. It cleans up from the crash, resets the process, and it goes and does its thing. Now, some of the other benefits that we get are not immediately clear from the bullet. One of the benefits we get is because in addition to the managed store, even though we're still using ESC, we've rewritten our logging inside of ESC. So jet logging is different. What we've done specifically is we've been able to actually persist the cache as we transition the database from the state from passive to active. Okay, so that gets you very, very fast failover, and I'll talk about how we did that a little bit in this session and a little bit more in the HA session later this afternoon. But basically what it means is you get much faster failover, failure isolation, and, like I said, a brand new store, brand new code. But it's, of course, it's tested and mature code, so you don't have to worry about newness from that aspect. Then we still have the replication service. It's still there, and it still coordinates with the store. The replication service still has Active Manager. It's also still responsible for issuing mount requests to the store. It's also responsible for tracking failures and doing a lot of the same work it was doing in Exchange 2010. That hasn't changed too much. But it works with the managed store. And it works with it in terms of some of the new behaviors that we have in there. The primary new behaviors are in another new feature that we have called managed availability. Okay, managed availability is high availability built into Exchange outside the DAG across the protocols. So we've extended high availability to everything about Exchange. And so you're going to hear about all these new things like probes and monitors and responders and how they work now. Okay, so another big difference there. But the replication service, it's still doing a lot of the stuff that it was doing in 2010. The only new thing that it's doing that's different is it's plugged into this managed availability pipeline so that there are new behaviors that Active Manager can invoke as a result of failures outside of the realm of the database. So for instance, the protocol stack dying. Something happens, IIS crashes. The database is still healthy, so that wouldn't normally trigger a database failover in 2010. But with managed availability, if we had that situation, we'll recognize that and try to fix the problem. And if managed availability can't fix the problem, then it will trigger the old school traditional database failover. Okay? I'll talk a lot more about that in a bit. Now, let's talk about what we're doing with ESC cache management, because the way in which we use memory, since we're now using a controller and service and worker process model, is a little bit different than the way we used to do it previously. Historically, we had the dynamic buffer algorithm that would go in, and it would basically calculate the amount of memory on the box, calculate the minimum working set that it thought Windows needed, and then allocate all the rest of that to the store. If something else on the box needed memory, the store would deallocate the memory back to the operating system, and the OS would then give it to whatever app is calling. Now we actually start up with a fixed working set, and the fixed working set is based on the number of databases that are on the server and whether or not they're active or passive. And then there's also one other setting that we look at. It's the max active databases. How many of you are familiar with that? It's not new in 2013. We had that in 2010. Max active databases, it's a property value that you can set on a mailbox server in a DAG that says, yeah, even though you can support up to 100 databases, I want to cap and make sure that at any given time there's no more than X number of active databases on this server. Sort of a way of controlling resources in a kind of a poor man's high availability system. Not too many organizations use that. They're happy just to let whatever databases need to come into service on that. But for those organizations that are using it, that's one of the other metrics that we look at. And then we take a fixed amount of the memory and we allocate that to the various worker processes based on whether the database is active or passive. Active databases get the lion's share of the memory. Passive databases get a much, much smaller share. They only get about 20% of what the active copy will get in terms of memory. So there will be additional memory overhead. There will be a little bit more memory that Exchange is going to need to use in 2013 than perhaps what we've used in previous versions. But the trade-offs there are you get a reduction in IOPS, and memory is a lot cheaper than storage. So it's actually a very, very workable type of solution. One caveat, though, and I don't think this will change for RTM, although I'm hoping it does, but quite frankly, I'm not holding out that much hope. And that is if you change the value of max active databases, or you significantly increase or decrease the number of databases that you have on a server, then you have to actually restart the services so that they can recompute. We do the cache computation at service startup time, so if the topology of the mailbox server changes so that you've created a bunch more databases or removed a bunch of databases, you'll want to stop and restart the services so that they can do their recalculation. Again, I'm hoping that goes away before RTM, but it might not, so something you need to keep in mind as your system matures through time. Okay, let's talk about IOPS reductions, because again, this is significant. It's something that we continuously work on year after year after year, version after version after version, to try and get our IOPS down as low as they can be. So what have we done? Well, probably the biggest thing that we've done to give us the reduction in IOPS is we continue to work on the logical contiguity of the store schema. Okay, so if you're not familiar with that term, there's three different ways that you can look at the information store. There's the physical contiguity, how we're laying data out on the pages in the database. There is the logical contiguity, how we store tables and columns in the database. And then there's the temporal contiguity, how a user views things in OA or in Outlook and so forth. We've made more changes to the schema itself. We are continuing to optimize the logical contiguity of the schema for performance reasons. Okay, so as an example, in Exchange 2010, we would store whole sorts of this kind of data in columns, in separate columns inside different tables. Okay, things that would be like message properties, for instance. Anytime we had message properties, they were in separate columns for the rest of the message table. And those of you who do databases know that as you need to jump from column to column or table to table, that's more and more resources and more time it takes to do that. We don't store it that way anymore. We're actually using binary large objects, or what we call blobs, for those of you who are developers. We're actually storing the message properties as blobs now inside the same table where the rest of the message is. So it's a much, much more efficient system. We're also, anywhere possible, we have eliminated or reduced our use of long-valued storage. Long-valued storage, obviously we're storing very long values, but that takes a bit more I/O resources to both write that and to read that out. So everywhere possible, we are minimizing our use of long-value storage. But we still use it. And everywhere we do need to use it, we're still using sequential I/Os like we did in Exchange 2010. So this also helps keep IOPS down as well. Then we also made some significant changes to the passive database copies. Okay, and I'll talk about a lot of this in the HA session, but just basically, in Exchange 2010, if you looked at the IOPS for an active and a passive copy, they were roughly equal. The passive copy was about 100% of the active copy IOPS. That's why if you use the mailbox server role requirements calculator, there's no differentiating between database copies, because it doesn't matter if it's a passive or an active, it's still the same IOPS. Okay? Now, the reason we had large IOPS on the passive was because of some of the work that we had to do. Okay? Part of that was around the checkpoint depth. If you're not familiar with that, the checkpoint depth is simply the amount of data we'll hold in memory before we have to commit it to disk. Now, in Exchange 2010, all passive database copies had a checkpoint depth of 5 megabytes, and that was intentional. If you only have 5 megabytes of data and you need to fail over and turn that passive into an active, that happens like that because we just have 5 megs of data to cycle through. So having that very low checkpoint depth gets us very fast failover. The problem with that, though, it also gets us more IOPS than we want. So we had to do something about that, and the solution to that was twofold. First, we increased the checkpoint depth so that it is equal now to what we have on the active. So the checkpoint depth for all databases in Exchange 2013 is now 100 megabytes. You don't have to worry about which is active or which is passive. It's the same checkpoint depth. But of course, with that large of a checkpoint depth, that could mean then we're going to have problems when we need to transition from passive to active, because we have so many more logs to play, and we don't have a cache built up at that point. So the ESE team spent some time rewriting ESE logging. It's the same database engine, but the way in which we log certain things has changed such now that we can persist the cache as we make that transaction. So that means now we get very, very fast failover, even with a large checkpoint depth. And I'll go into even more detail in the HA session as to how we achieve that, but that's a big savings. The result is basically the passive copy is now 50% of the IOPS of the active copy. So right there, just right there, is a 50% reduction in IOPS over Exchange 2010. So if you were to extrapolate that reduction, starting with Exchange 2003 being sort of the benchmark at our one IOPS heavy monolithic user, we have reduced IOPS so significantly. Anybody want to take a guess at the number? And in fact, if anybody guesses the number exactly, you'll get a car. So raise your hand. Don't just shout it out if you want to take a guess. Yes. No. Yes. No, we're talking about how much IOPS have we reduced going from 2003 to 2013 in the form of a percentage. So like we went 70%, 70%, some value. What's the long number? Yes. 5. No, that's way too small. We're talking 2010 from 2003. Yes. No, so you're saying it would be 95% reduction, is what you're saying. Is that what you're saying? You're wrong. Next. You're close, though. Yes. You got it. We actually say plus 97, but if you do the actual math, it does work out to 99.5. Why aren't I saying 99.5? Because this is pre-release, and I'm not comfortable with 99.5 being the actual number. But right now, if you do the math now, with anywhere from a 48 to 76% reduction from Exchange 2010. The 48% would be your cached mode clients. The 76% IOPS reduction is your online clients. Okay, so that is a significant reduction in IOPS. 97% or greater, you can get your car later, over Exchange 2003. If you extrapolate to the next version of Exchange will give you IOPS. No, it won't. It won't. It won't. I was so worried about doing that joke because I swear someone was going to take me literally, but it won't. Well, I don't know if it will. It doesn't exist. But that was a joke. But yeah, significant reduction in IOPS. Okay, 97% over Exchange 2003, that's impressive, but it's over 10 years. 50% over Exchange 2010 in 2.5 years, that is impressive. That's some quality work. And of course, that ties into the ability to support larger mailboxes. With these larger data sets, you're going to want a larger mailbox. And to support that larger mailbox, you can't hammer the disk. You have to be a good citizen on the disk. And we've done a lot of work to support these larger mailboxes. And again, when we talk about larger mailboxes, I don't mean 25 or 50. I'm talking 100 gigabytes and larger. 100 gigabyte is actually one of the minimum sizes we use for testing Exchange 2013. So that just shows you the kind of scale that we're talking about. So larger mailboxes, when we talk about a mailbox, we're talking about the aggregate of a mailbox because, as you probably know, you have the ability to give all of your users two mailboxes, a primary mailbox and an archive mailbox. The primary difference between them being the archive does not sync down to the OST and the primary does. Okay, archive stays there, primary comes down. But when you do the math, it actually doesn't look so bad. You figure with a relatively heavy workload, one day I get 150 items, that works out to be 11 megabytes per day. Okay, so after about 4 years, that's only an 11 gig mailbox if I save everything. That's without deleting everything. That is a very manageable mailbox size. So when we talk about giving information workers 1 to 2 years worth of mail, it's something as a good corporate IT department you have to do. Because if you don't, they're going to go to Hotmail, or they're going to go to some other service and get a free 25 gig mailbox and start using that. And they're going to wonder, how come you can't deliver the same in a corporate IT environment? And now you can, and you can see it's very reasonable and economical to do that. You increase their productivity, you get rid of PST files, which we've been trying to do for a long time, and which customers would like to get rid of for a long time. It also allows you to eliminate third-party archiving or stubbing solutions, which are typically not that good for Exchange. So there's a lot of benefits to having this large mailbox value proposition. Now, of course, there is this conundrum. I want a really large mailbox, but maybe I'm using Outlook 2007 or Outlook 2010, and the OST file just can't scale that long enough. Can't grow that big, if you will. So maybe instead you decide to upgrade to Outlook 2013, because that has a new feature in it that was requested by folks on the Exchange team. And that new feature is an OST size control. It's a little slider bar that you get that allows you to say, how much mail do you want to sync to your OST? That could be 2 months, 6 months, 12 months, or our personal favorite, 2 years, which is if you slide it all the way over. So this way, when you think about it, for those of you struggling with how do I carve up the mailbox and which kind do I give them and how much of which size and so forth, just give them a large primary mailbox. And if they have OST size issues, use Outlook 2013 and the slider control to deal with that. And when you think about it, you start to realize, gee, maybe I might not need to use that archive mailbox at all in that case, because this could solve 90 to 95% of the reasons that people would typically use an archive mailbox. So you can give them a very large primary mailbox, but still control how much data gets sent down. And what's beautiful about this is it's, of course, a cache mode client. So the user experience isn't diminished at all. If they do a search in Outlook, it's going to search the OST, and if the information's not there, it's going to search the online store and bring everything back for them. Conversation view is still going to go across both the online and the cache mode stuff. So you still get all the same user experience, but you don't get the high overhead of a very super large OST because you've decided to give them a very large mailbox in addition to that. Now, what else have we done? Well, we got rid of scheduled maintenance. Turns out we didn't need it. No, just kidding, we did. But we got rid of it as scheduled maintenance. Okay, because when you think about it, in today's world, with large data sets and 24/7 access, 365 days a year and so forth, it really doesn't make a lot of sense to carve away out a portion of X time to do some form of maintenance on a database. It just doesn't jibe with today's reality of messaging. So we did away with it. And largely, it was previously in the form of two assistants. The store assistant that would go and do things like clean up deleted items and MFM and some of the other functions, and then the store directory, which would go and reconcile deleted or disconnected mailboxes with AD. Okay, so that functionality is still important. It's just not part of any scheduled maintenance anymore. Instead, it's part of time-based assistance. Okay, and these are time-based assistants. We call them time-based, but the reality is they're running all the time. They're running, they're on, but they don't do anything until they get the signal from the system that says there's enough resources available. So if they're doing a task and users come in and they start using up resources, we throttle back or we'll stop that task. If the server's largely idle or if there's free resources available, we'll spin up tasks and we'll try to get that maintenance done. And we don't need to do it as quickly as we used to. We used to tell you, make sure you get scheduled maintenance completed within a week, or 2 weeks maybe at the most. Even that was extreme. We'd like to have it done within a week. Now, make sure it gets done within 4 weeks, 5 weeks. It's not that important anymore. It's not that necessary anymore. We also had the background ESE database scanning. And this was actually somewhat fairly aggressive in Exchange 2010. This was also causing some additional IOs, particularly with respect to some very aggressive pre-reading that the passive copy would do in hopes of trying to build up a cache that it wouldn't be able to use anyway. We don't do that kind of stuff anymore. Okay? And because we don't do that, that now translates into another reduction in IOPS. It makes things much faster. And the last change we made is there used to be this periodic background task that would look at the user's mailbox size and look at their quota settings and then send them messages repeatedly over and over and over when they were out of quota. We don't do that anymore. There's no need to do that. Particularly if the user's on vacation, we don't need to send them 20 messages while they're gone to say, you're over quota, each message going over quota even more. Now, we do it at logon time. Okay? Somebody logs in. If they're over quota, boom, we give them the pop-up alert, and they find out that way. Okay? Much more efficient. All these little things that we've done, all these little changes that we've made have further reduced IOPS and further made the system more efficient for you. And by the way, I didn't mention it specifically, but the resource management that we use is another brand new feature in Exchange 2013 called Workload Management, or WLM for short. We used to call it throttling in Exchange 2010, but it's doing a lot more than throttling now. So now we call it Workload Management because it's looking at all the resources on the box and deciding whether or not things should be throttled back. Should we throttle back mailbox moves because they're generating too much logs? Should we throttle back user activity because they're generating too much CPU use on the mailbox server? Or do we need to throttle back some of these time-based assistants that run under workload management simply because there aren't that many resources available in the box? Okay, so that's where that comes into play. All right, let's talk about modern public folders. How many of you are using public folders today? All right. How many of you want to get off public folders and never use them again? Okay. How many of you want to continue using them? Great. Well, I can satisfy you both because you have your choice. You can continue using them or you can not use them. But we call them modern public folders. Well, we call them public folders, but we also try to call them modern public folders because we want to distinguish between the old legacy public folder model and the new modern public folders that we have. So let's start with some of the key differences. There's no public folder database. That doesn't exist anymore. There's only a mailbox database. Public folders are now based on the mailbox architecture. And I say now, but technically, it might surprise you to know that that's not entirely accurate. The public folder infrastructure that we have in 2010 and earlier, you might be surprised it's really a special kind of mailbox. That's all your public folders are inside that database is really just one mailbox with carved up folders and a different replication mechanism. Okay, it was a specially replicated mailbox, but we called it public folders to distinguish it from actual mailboxes. But now in 2013, the actual true architecture, it is a mailbox because there is no public folder database. So the public folder is now a new type of mailbox that you could create. Now there's two types of public folder mailboxes. One is the public folder hierarchy mailbox. That will be the first public folder mailbox you create. The hierarchy, as its name implies, stores the hierarchy of all the folders. The second and subsequent public folder mailbox you create are called content mailboxes. Okay? And they, of course, hold the content. We no longer use a multi-master model. We have a single master model now. And that means there's only one mailbox that has the writable hierarchy. There's only one mailbox that has the writable content. And they don't exist in multiple places. So if a user needs to access public folder content, they will go to a public folder mailbox. It will look up in the hierarchy because every public folder mailbox has a copy of the hierarchy. So it'll look in the hierarchy, find out where that public folder is, and then go and access the mailbox that contains that content. And you can start out with one mailbox. You have your hierarchy in one content mailbox. As that gets larger or too full or you want to spread things out, add a second one or add a third one or add specialized ones for projects or groups or almost any way that you'd want to carve it up. Now, because it's a mailbox, in a mailbox database, you no longer have public folder replication. You don't have to worry about public folder replication. If you do want high availability, though, because it's a mailbox in a mailbox database, it's just another mailbox from the DAG perspective. And so we'll replicate using continuous replication. We'll create passive copies of that database. It could be a mailbox that sits side by side with user mailboxes or resource mailboxes or shared mailboxes or the new site mailboxes that we have in 2013, which is a combination of a mailbox and a SharePoint site. So it has all those benefits. But from the administration perspective and from the end user workflow perspective, it's largely the same. Users probably won't notice any difference at all. The public folders look just like the same tree that they're used to. It will access the same content that you can have, whether it's messages or attachments or free docs or anything that you put in there. From the end user perspective, everything is exactly the same. From the administrator perspective, everything is also largely the same. The only thing that you need to perhaps put some thought into from a design perspective is the fact that, again, the content's only in one place. It's not a multi-master model where you could have content replicated geographically closer to other users. It exists only in one place, and so when it gets accessed or changed, it's being done so only from that one place. So that is a significant difference to keep in mind. But again, it's up to you if you want to use public folders. Now that we've moved forward, and now that Outlook 2003 is no longer part of the supported clients, there are no Outlook clients anymore that require public folders. So public folders are now completely optional for you. And you might decide that they actually don't work for whatever collaboration or sharing solution that you want. You might find that site mailboxes work better for you now, or you might find that SharePoint works better for you now, or some other set of tools that we have. But if you are using public folders, they are here, and they're available for use. They're very different, but they're here. So how does it work? Well, the first thing I want to point out is that public folders can be used by anybody, okay? The Queen of England, pizza delivery man, even Santa, I hear, is using public folders for tracking his naughty and nice list. No, not really. But as you can see, they're for everybody. So the user first, they contact their public folder home mailbox. So we still have that concept of a home folder mailbox. That is there so that the user can just have one place that they go to query the hierarchy. Again, every public folder mailbox has a copy of the hierarchy, but only one of them is the actual hierarchy mailbox that's writable. So they access the public folder, and they want to get their information. So they query the one that's their home folder, and it looks in the hierarchy to find out where the content is. So because the content lives in that one specific folder, in that one specific mailbox, all content operations therefore happen against that one folder and that one mailbox. Okay, we don't have to go through a bunch of different ones. If it turns out that it's in a different location, again, they'll just connect to whatever public folder mailbox has the right content set. So if they're moving from folder to folder and those folders are stored in separate mailboxes, they'll be jumping from mailbox to mailbox behind the scenes, and they won't notice anything at all. It'll be completely transparent to them. Now, anytime there are changes written to the hierarchy, if you give users permission to create new folders and they create a new public folder in Outlook, that's a change that gets written to the hierarchy. That is intercepted by the public folder mailbox they're working against and forwarded to the writable copy of the hierarchy where the changes are then made. And then once those changes are made, they're sent out to the rest of the mailboxes internally. So that hierarchy change goes around right away. Then, any other public folder mailboxes that you have, they just sit there and they'll listen for changes. So anything that the user's doing, creating folders, removing folders, adding content, editing content, anything that they're doing, the public folder is just collecting it all and grabbing it all, and all of that activity is happening against their active mailbox, or that the mailbox that has the content located in it. And again, as I said, when it gets full, and full is a relative term, you decide how large you want to grow them. So when it gets up to whatever size limit you decide is appropriate, then you simply create a new mailbox, and new content will go into that one. Okay, it's a very simple and straightforward process. Okay, and we'll talk about how to migrate from legacy public folders to modern public folders in tomorrow's deployment and coexistence session. All right, let's talk about the new search infrastructure, because this is also key to the user experience as well. So we're using FAST. How many of you have heard of FAST? All right, that's great. But it's integrated. Okay, it's fully integrated with Exchange. You don't buy your own FAST server. You don't buy FAST licenses or anything like that. It's integrated the same way we had Microsoft Search integrated in previous versions of Exchange. But FAST is our actively developed search platform that we're leveraging across Office. So SharePoint has it integrated as well, although they do some special and custom things with their engine. We're using it. Other apps in Office are using it as well. It is the search engine that we have chosen for the new Office. Significantly improved query performance. Okay, some on the order of 20 to 35% faster querying in 2013. Also improved indexing performance as well, so we can index much, much faster than we could before. Okay, I don't have any statistic on that because we're still looking at some of the numbers there. But let's talk a little bit more about it. So I know a lot of you had your hands up when I asked who's heard of FAST, but I just want to give you just a real quick FAST primer so that you can understand what we're talking about. So FAST has these two main components. One is the content transformation, and the other is the IMS, the integration management system there. And so basically the way it works is documents will come in, and we'll run filtering against them, we'll run word breaks against them, we'll process them, we'll pass them off to the writer, and then they'll finally go off to the core catalog itself and sit inside the index file on disk. When somebody does a search, they want to search for stuff, they're doing that through IMS, so they'll do a query. We will parse that query and then reconstruct it to do a form that we can send to FAST. We'll run it through FAST Query Engine. It will query that content catalog and then return the results to the calling user through Outlook, through OA, through EAS, whatever interface they were using to do their search query. So it's very, very similar to what we had with Microsoft Search, except that there's a couple more moving parts and a slightly different way of us doing things. Now, the search infrastructure, and this is where we start to differentiate, this is all happening in the mailbox. Okay, so we're not talking about CAS, even though stuff can come in, like SMTP and client activity can come in and be proxied through CAS. All of this is happening on the mailbox. Now, when you think about how we used to do indexing, it was really, really inefficient. Okay, so think about my sending a message to 3 recipients. Okay, as soon as I send that message, it's going through transport, it gets bifurcated, it gets sent to 1, 2, or 3 mailbox databases, and then we index it. Well, there are 3 separate messages, we're indexing it 3 times. Let's say that one database that they all went into happens to be replicated, and there's 4 copies of that database. Okay, well now we're indexing it 3 times on each copy, so that's 12 times. So now let's take this message lifespan and let's expand it out a little more. Let's say it stays in the system for, I don't know, 3 years. We'll just say 3 years. Okay, so now during that 3-year period, it's conceivable that I'm going to have to reseed at least one of those databases at least once. You know, disks are going to fail, stuff's going to happen. Over that time period, I'm going to have reseed activities. So every time I reseed a database, that's 3 more times indexing. And if I do that just a couple times a year over those 3 years, over a 3-year period, when I'm done with those messages, I'll have run indexing on it about 72 different times. Okay? That's not good. That's really bad. That's hugely inefficient, and there's no reason to index it that many times. So how do we get around that? Well, the way it works in 2013 is mail will come into transport, and we won't bifurcate it at this point. We will take the one message, regardless of how many recipients are on there, and we will pass it to the CTS component of FAST that exists on transport. Okay, so now we have this one message. It can be the same message sent to 3 people. We've indexed it once. Okay, came in, hit indexing. It's only been touched once. Okay, once it's done, CTS pops it back into the transport pipeline, says I've indexed it all. Go ahead and send it on its way. Transport takes it, passes it down to the store, goes into the database is replicated. Once the message, see that little message icon on the database, that indicates it's hit the database now. Once it hits the database, the Exchange Search Service has a subscription event that triggers, and that tells it to go into that database and retrieve the message and its properties and its contents. So it will go and get that, pass it to the CTS that's on the mailbox service. It will read the content, and then index it in the index node, and then ultimately stored in the index. So this same message sent to 3 people has only been indexed once, even though it's gone through the whole entire system. So right there, just using the basic example, the first message coming into 3 people, that's already 1/3 of the indexing that we would do on that message. And as you might imagine, that extrapolates through other operations such as replicating the database or reseeding a database copy because it's failed. Now, let's say we do have to replicate it. When we replicate it over, we are still sending all indexing replication over the MAPI network. Okay, we're still not using the replication network for indexing traffic. So those of you familiar with the DAG, we're doing that in 2010. We're still doing that in 2013. But we send the data over there, and because we already have our word table that we got through the first CTS process up in transport, we don't have to go and re-index it. We can actually just go into there and read the word table out of there and send it over to the index and store it that way. So it's not a re-indexing. It's copying something that's already been indexed and incorporating it into the second copy of that index. So again, same message sent to 3 recipients and replicated to another database, but still only indexed one time. Okay, so it's significant savings here. All right, the last section I want to talk about are the transport-related changes. We already talked about what's happening with transport on the client access server. Okay, that's the SMTP proxy. That can do connection filtering, sender filtering, and recipient filtering, but no content filtering, no queuing, no state, no bifurcation, no categorization. It's just a simple SMTP proxy. But SMTP has to have somewhere to proxy it to, and that's the transport services on the mailbox role. What we used to call hub transport is now the transport services on the mailbox role. Okay, so we have 3 components. We've got the Exchange transport service itself. That is the stateful service. That's the one that's responsible for processing the messages. That's the one that has the transport rules engine, the policy engine, the mail.q file, the bifurcation, the categorization. It's what we used to call hub transport. It's now simply the transport service. Then we have the mailbox transport delivery, and that's receiving mail from transport and sending it to mailbox, and the mailbox transport submission, which is taking messages from the mailbox and injecting them into the transport pipeline to send them out on their way. So it's very, very similar to the components that we had, except now it's all inside the mailbox role instead of on what we used to call hub transport. So transport receives all inbound mail for the organization. It can also submit all outbound mail for the organization. And it's submitting it either through the mailbox server that is doing the DNS resolution and sending it, or by sending it to a CAS and having CAS forward that out through SMTP. It also does all the transport rules, all the content filtering, all the antivirus stuff. So a lot of the heavy protocol agent work that you're used to seeing on hub transport today is being handled by the transport service in mailbox. It does the mail flow routing. It's responsible for queuing in the mail.q file. It's responsible for shadow redundancy, which I'll talk about in a bit. And it's also responsible for SMTP extensibility for developers who want to do custom SMTP workflows. So you can see what the architecture looks like. This is the transport pipeline showing both SMTP from the mailbox delivery and SMTP to the mailbox submission service. It looks very similar to what we have on the CAS, except the CAS has a lot fewer components because it's not doing as much work. But you can see here where the submission queues are, where the categorizer lives, where delivery queues live. It's not shown up here, but this is also where the shadow queues live as well. And it's basically almost everything you loved about the hub transport in 2010, except, again, it's built in and part of the transport service in Mailbox now. So this is another way of looking at the functionality to and from the Mailbox store. Remember, I talked about the only place that we're using MAPI. And remember, it's MAPI talking to components on the same box. So what that really should say is MAPI local RPC. Because when you think of MAPI, you think RPC, but it's not RPC going off the box. It's local RPC. So it's very quick and fast, all happening on that one island server. And again, it's just the store driver and the deliver and submit component that are doing that. We used to have them set up as separate services, the mailbox submission service and the store driver service. We've combined them all into one, into the transport service now. So all the functionality is still there. They're just not implemented as separate services anymore. So there's two separate services to handle the mail delivery to and from the transport service. That's the delivery and the submission service that I talked about. Those are doing things like taking messages out of your outbox, putting them into the transport pipeline, or getting messages from CAS that have been proxied and putting them into your mailbox. I mentioned that it uses local RPC. It's stateless and doesn't have a persistent storage mechanism in this case. It's the transport queue that's the persistent storage. So it's a very lightweight, simple SMTP stack. For message delivery, the mailbox transport delivery service is responsible for that. If it can't deliver it, it's also responsible for delivering any delivery reports. Non-delivery report, successful delivery report, journaling message, rerouting the message, retrying the message, and so forth. It's responsible for all that functionality. So this is a very simple example of what it would look like. Here we've got mailbox 1 and mailbox 2 in a DAG. We're replicating the databases. The blue is the active copy. The yellow is the passive copy there. And again, we've got mailbox servers that we're looking at. So a message comes in. It goes into transport, talking SMTP. Transport will also talk SMTP to the mailbox transport component, which will then talk MAPI to the database. If something happens at the database, you see it fails. It goes yellow here and turns blue there. Again, the message will come into transport. Transport will say, no, the active database is over here. You need to go over here. And then it will talk and deliver the the mail message that way. So it's very, very similar to how we're doing the CAS proxying and how we move the CAS connection over. Same thing with the SMTP. We're always targeting the mailbox database that has the active copy of the user's mailbox. So as that active copy moves around, so does the protocols and communications, and all access related to that moves with it. Okay. Some of the transport availability changes. So here we're talking about HA for transport. We've made some pretty significant changes here as well. One of which is, how many of you have heard of shadow redundancy? Okay, so shadow redundancy is still there, but it's been enhanced. Okay, and in fact, you now have your choice. You can have the sort of the legacy style shadow redundancy, which is doing what we're doing today, trying to persist another copy while we're trying to deliver the message. Or you can have what we now call guaranteed redundancy. And guaranteed redundancy is where if we can't redundantly persist the message, we won't accept it. So you have that choice. If you want to ensure that every single message that enters your transport pipeline is highly available, then you would turn on guaranteed redundancy. And in doing so, only messages that couldn't be persisted for whatever reason would not make it into your pipeline. Okay, so that gives you another level of protection for your messages there. Now, every DAG represents a transport HA boundary. Remember, the DAG is the collection of mailbox servers, and it's mailbox now that has all the roles jammed into it. Okay, so that means now that the mailbox becomes the transport HA boundary. And in fact, we have a new name for that. We call it the routable DAG. Okay, but don't be confused by that name. It doesn't mean we're routing things across DAGs and whatnot. It just means that when we try to redundantly persist messages within a DAG, we always try to persist it on a server that's also a member of that DAG. And in fact, extending that out even further, if you have your DAG extended to multiple Active Directory sites, then in doing so with shadow redundancy, you get site resilience for transport. Okay, just by extending the DAG to multiple sites, that's enabled by default. And then any resubmits, because maybe you had a lossy failover or something happened, you had to recover a lagged copy or whatever, they're all fully automatic. Okay, so there's nothing an administrator has to do to request redelivery of messages that might have been lost through a lossy failover. That is still all completely automatic, and that comes in through what we used to call Transport Dumpster, but what we now call Safety Net, which I'll talk about in a moment. But the idea here is that if you choose to, you can enable it so that every single message that goes through transport is redundantly persisted or it will not be accepted. Okay, that's a configuration choice you have. It's off by default. If you turn that on, you'll get that behavior. Now, shadow redundancy, it's the same fundamental concept, except our implementation is slightly different. And again, it goes to the fact that we give you the option to guarantee redundancy now. So that's where the implementation is different. We want to make it redundant on another server in the DAG, or another server in the DAG and another site for site resilience purposes. And we want to make sure so that if the server that's about to deliver the message, if it suffers some catastrophic failure and it never makes it from the mailbox transport service to the mailbox store itself, that we have another copy of that message somewhere that can eventually make its way into the user's mailbox. We also have the same concept of the primary copy and the shadow copy, where the SMTP server responsible for delivering it is the primary owner. Those that keep a copy are the shadow owners. And of course, if the primary isn't able to deliver it, the shadow copy will be invoked, and that will be sent through the transport pipeline. Guaranteed redundancy, if you turn it on, it's called reject on shadow failure. Now, one of the caveats with this, because of the way this works, we recommend that if you are going to use guaranteed redundancy, that you have a minimum of 4 transport servers, 4 mailbox servers with the transport stack. Now, I understand that is a little bit of a departure from what we had historically, because historically we've been trying to get down to as few servers as possible for HA. So for instance, if you think about 2010, you could have HA for a DAG with as few as 2 exchange servers. The idea, though, with reject on shadow failure is 2 servers isn't enough. Okay? Because if the smallest number of servers we support is a 2-member DAG, and we need at least 2 places to do the redundancy, what happens when one of your DAG members is down? Or if you take that server down for maintenance, or it's just otherwise unavailable? Well, that will cause transport to start rejecting every single message because it doesn't have another place to make it redundant. So we recommend a minimum of 4 servers if you're going to use this feature. That way, you could take one offline for maintenance and still have breathing room to suffer an unexpected failure of a second server, and you'll still be left with 2 servers, which is the minimum that you need to always have it turned on. Okay, so keep that in mind. That's where that comes from. It's a sort of a resilience mechanism. If you don't have at least 4, you can still do it, but if you get down to where you just have 1 server left and you leave this turned on, transport stops. It will not accept any more messages because it can't guarantee redundancy without a second place to make it redundant. So keep that in mind. Now, messages can be made redundant in the same DAG. If you're using online stuff, they can be made redundant through Forefront Online, or they can be made redundant just by going across another site and by storing in a mailbox server in a different AD site, giving you site resilience. And there's also a configurable amount of time as well. So you can say, keep trying for X minutes and then reject if you can't deliver it. Okay, so in most cases, you won't need to adjust that, because transport's usually really fast. In fact, when you think about the delayed acknowledgement version of shadow redundancy that we had in 2010, that was something that we only had the clock running for 30 seconds, because 30 seconds is a very long time in which to deliver a message. So chances are you're not going to have to adjust any of these settings. But the adjustment is there if you need to. Now, scoped redundancy, that's similar, except that you're scoping the redundancy to a set of mailbox servers in a DAG, or a set of servers across multiple sites, and so forth. It's very similar, except that it works with both DAGs and DAG-less environments. Obviously, we can't expect every single customer to run DAGs, so we want to give you the ability to do high availability and transport without necessarily having a database availability group available to you. So this is the mechanism by which we do this. And the way we do it in a DAG-less environment, it's always happening in the same local site. Okay? We don't want to, in a DAG-less environment, scatter messages across multiple forests if you have them. Okay? We want them all located in one nice single site in a DAG-less environment. If you do have a DAG, we'll spread them across the DAG. If you have a DAG extended across sites, we'll spread them across the DAG and across sites and give you both HA and site resilience. But if you don't have a DAG, everything gets redundantly persisted in the same local site. Okay, safety net. Safety net's probably something you never heard of. Transport dumpster, who's heard of that? All right, safety net's the new name. Okay, safety net, though, was not actually Transport Dumpster in 2010. SafetyNet was a separate initiative and separate code that we created in Office 365 to have basically to say we're just going to persist all messages. We're making all messages persisted here through SafetyNet. We're going to hang on to them until they've been delivered for X amount of time. You get to decide how long X is. Okay, here's how that works. In Transport Dumpster, we only save messages that were going to a replicated database. So in Exchange 2010, if you had mailbox databases that were not replicated, Transport Dumpster did nothing for you. It was only there to get messages back to a database that had suffered a lossy failover. We've made 2 changes to that. Transport dumpster is gone in terms of name. It's been replaced by safety net, and safety net covers all messages. All messages are redundantly persisted in what we used to call the transport dumpster area inside the mail.q file. We now call that safety net. The second thing that we've done is we've integrated safety net with lagged database copies. And we've made it, in doing that, much, much easier to do the activation. You no longer have to do log surgery or figure out where you want to sever the log stream. Unless you want to do that, you still can, but you don't need to anymore. Here's how it works in today's world with 2013. You have a lagged copy, and you say, I want this lagged copy to have a 7-day lag on it. Great, 7 days. You set safety net to store 7 days worth of mail. Okay? When it comes time to activate your lagged copy, you play the logs to where you want them played, all the way up or maybe part of the way up, depending on where you want to break it or don't break it. Once the log replay is done, that lagged copy, as it comes online, will automatically request redelivery from any missing messages for that outage period from safety net. And then safety net will deliver all of that missing mail, thereby activating your lagged copy, not quite automatically, but almost automatically. There's no administrator intervention required in order to have safety net redeliver messages to a newly restored or newly activated copy. And it doesn't have to be an activated lag copy, by the way. You could be restoring a copy of a database from a backup, and the backup could be several days old. And as long as you have that data in safety net, once you've restored that data, it'll go ahead and bring it back up to date and get all those messages back. Okay, pretty cool stuff. So it replaces transport dumpster. You're not going to see the term transport dumpster anywhere in the documentation anymore. You'll see the term safety net, and that's what we're going to talk about because that's the only feature that exists. It's just safety net and shadow redundancy right now. But again, it's a great piece of code because it was learnings that we developed from the cloud that now come down and benefit the on-premises environment as well. So it's beautiful when things work out that way. All right, the last thing I want to go through is this somewhat complicated animation here, but it's going to basically walk you through how we do transport HA. So I know this looks like a lot of stuff here, but basically what we have are 2 DAGs. MBX 1, 2, 3, and 4 are in one DAG. 5, 6, 7, and 8 are in the second DAG. And as you can see, both DAGs are extended across multiple Active Directory sites. So what's going to happen is we've got a message coming in, and it's got 3 recipients, R1, R2, and R3. And it's coming in via SMTP. It could be coming in from CAS or Mailbox or Combo Roll or some server. It enters transport. So the first thing that we want to do is we want to invoke shadow redundancy. Anytime a message enters transport, we want to persistently make it redundant before we will deliver the message. So it comes in, goes into transport, and we set the recipient state. In this case, we're ready to deliver to these recipients, so the recipient state is active. We're ready to go ahead and send this message in. So we go ahead and we route it through transport. And the first thing that we do, because this is a DAG extended to multiple sites, you see the first thing that we do is we take that message and we send it over to transport on the other site, picking one of the servers at random, and it's sent over there and it's made redundant. So if something happens here, if this whole side were to blow up or disappear, we have the message persisted over here, and we can still get it if we need it. So it's over there now. It's been made redundantly persistent. We've done that. We've taken care for it. We do have to wait for the acknowledgement from the shadow server to do that, so we get that acknowledgement back. And then we'll send the acknowledgement to the sending client or server at that point. So we're still doing a form of delayed acknowledgement in there. We don't send that last 250 OK to the sending server until we have it redundantly persisted. Then, after we've done that, then we'll begin the delivery process. You can see recipient 1 was over here, recipient 2 ended up over here, and recipient 3 is sitting in the queue because its mailbox database is not available right now. So it's something that's just waiting to be delivered. The other messages, as you can see, for R1 and R2, you can see the little mail icon next to the database. That's the indication that they're in the database. But recipient 3, that still has an access state. And you can see up the top the recipient state has changed. So recipient 1 or 2 are waiting for database replication to occur. They're not going to acknowledge delivery of that message until they hear back from the replication pipeline that the message has been replicated through continuous replication to another copy of that database. And it's only at that point will we go ahead and release and say, okay, this message has been redundantly persisted, and we can go ahead and acknowledge everything and deliver it. Now, we send that over there. We make it redundant. We deliver it over here. We're waiting for database replication again. We're waiting for continuous replication to do its thing. It does its thing. We replicate it around, and everything goes from a waiting state into a process state. Then the very last thing that we do, and it's not a part of this animation, but once we have completed this process, and once we've determined we no longer need to persist or retrieve the message, at that point we'll go ahead and delete it from the shadow queue after SafetyNet has acknowledged delivery. And at that point, it's up to SafetyNet itself to maintain the persistence the same way Transport Dumpster used to do it, except that now it's based on the number of days, and it doesn't require feedback from the replication pipeline. Okay, so big significant change here, but it gets you both HA and site resilience for SMTP messages. All right. And then, of course, you can see the next step is the logs getting replicated. You can see them going from database to database. And once the logs have been replicated, the state goes from waiting DB REPL to processed. Same thing on the bottom. Once we replicate the logs over there, whoops, it goes, sorry, I keep hitting the wrong button. It goes from waiting to processed. Ah, man, it's going too fast. Waiting to processed. There it goes. All right. And then we delete the message from the queue once the SafetyNet has acknowledged it. All right. So that is architecture part 2. Now, there's a lot of related content. We still have the HA session later on. There's still a lot of link sessions going on. I've got the deployment and coexistence session tomorrow as well. So still a lot of stuff to do. But let's have a quick look at the time here and see how we're doing on time. Oh. Turns out we're like 10 minutes over. So the keys in the cars are going to have to wait. We're going to have a car and key blowout later on today. How many of you are able to, first of all, how many of you are coming to the HA session? All right. How many of you are able to stay a little late for that? Is anybody not able to stay late for that? Anybody? Anybody? One person. Okay, if you're not able to stay late for that, come up and see me. If you are able to stay late for that, please do, because I promise it'll be worth your while. Like I said, there's stuff in there that nobody outside of Microsoft really know about, and you guys are going to be the first people to hear it, so hopefully you can make it. We are over, so I'm going to clear the stage and let the other presenter get on. I'll be off to the side here if you have any questions. Otherwise, thanks for coming, and I hope to see you at the HA session.